All right, we're back. We're going to be on page 65, but what I'm doing is I'm backtracking. I told you to do this. I'm now going to do it. I'm going to graph this function on my calculator and see what it looks like. So we're going to graph it, and I don't know. It's going to be brutal to type in. That's really the main thing I'm not looking forward to. So I'm going to do this in a new problem. So doc for enter, and then a graph page, and you can see I'm on 2.1. So any variables, anything from problem 1 is still stored in 1.1. And now everything is cleared out. So I'm on F1, nothing is defined anywhere, so that's pretty good. So let's see, I'm gonna do the sine of the arctan of the secant of the arc sine of the cosine of the arctan of the secant of the arc sine of x. And press enter. This is gonna graph it. Here we go. Big moment here. What? Right? Look at that. That's the whole graph. Let me zoom in on that. So this is it. This is our entire graph. So what is going on? I don't know. I mean, that's like a very simple looking graph. What's helpful about this is that, I mean, I can trace. Let's see. Let's trace and see what we think the domain of this is. Well, okay, so it looks like I can get kind of arbitrarily close to 1, but if I get to 1, it's undefined. But I can get arbitrarily close. Eventually it'll, ooh, look at that. That looks like root 2 over 2, which maybe it is. Eventually, oh, whatever. And I should be able to do the negative, okay, rounded, but that's not right. That's rounding, right? So at 1, it's undefined. -1 should also be undefined. Let me do it. 2, 3, what? Oh my God, I don't know what has happened. Okay, -1 should be undefined. How about -0.9999? Why do you not work anymore? Okay, so I mean, it kind of worked. Anyway, the domain is definitely, for some reason, -1 to 1, not including -1 and 1. So I'm not sure what's going on there exactly. We're going to want to work that out. But it does tell me that I could take any fraction that is whose absolute value is less than 1 and sub it in and get a working problem. And that's essentially how I do a lot of these, is I come up with some stupid looking function like this. I graph it, I look at it, and I think like, okay, so I can plug in 1/3, sure. And then I do. And then you get a problem that you can definitely do. So it's kind of a weird process, but it's useful. And let's see if we can come up with like where, like why? How does it work? How is the calculator doing this? Well, it turns out that the calculator is basically doing what we've been doing, but instead of using a particular ratio, it's just using x, right? So it's drawing triangles for inverse trig functions, and then it's like doing whatever it needs to do. So we already know how to do these. There's just a little bit of extra information that we need to worry about. And that's going to be the domain. Like, what is happening with the domain? So here, for example, I'm going to try to find the cosine of the arcsine of 4x. But there's an issue with that. So arcsine of 4x. The issue is 4x, right? I need to make sure that whatever 4x is, it's in the domain of arcsine. Otherwise, I can't do it. So what is the domain of arcsine? So for arcsine, I need this to be true, right? That has to be true. So I'm going to do the arcsine of 4x, which means for this problem, I need 4x to be between -1 and 1. Because if 4 times x is not between -1 and 1, then I can't do the arcsine of 4x. So actually I need x to be between -1/4 and 1/4. So this is going to be the domain. So I'm going to save that now. And now I'm going to try to do the problem, right? So the problem is I need the cosine of the arcsine of 4x. If it was the cosine of the arcsine of 3/7, I would be drawing a triangle, and opposite would be 3, and hypotenuse would be 7. Here, I'm going to draw a triangle. It's just that in this case, so let's call it like theta, the sine of theta is 4x, right? So opposite of 4x and hypotenuse is 1, which is simple. Like that's all you can really do there. It's not a big deal. So here, the missing side is going to be 1 squared minus 4x squared. Or you could and probably should just write 1 minus 16x squared. So that's what we get. Now the question becomes, what's the cosine of theta, right? So this is cosine of theta. Well, the cosine of theta is going to be radical 1 minus 16x squared over 1, which is just radical 1 minus 16 squared. But the answer to the question, so I'm going to say, therefore, the cosine, you don't really need to do this, but I think it's better to do it, and you should always try to do the better thing, is this. So we have to consider the domain. Once we have the domain, just like go to town on the algebra, and it'll be fine. So we get this, and that's our answer. So maybe I'll highlight that. So this means, what does this really mean? It means that if I asked you to do this problem, what the heck? I didn't actually write the answer. This equals radical 1 minus 16x squared. There you go. That means if I asked you to evaluate this function at x equals 1/20th, you don't actually need to do like the triangle thing. Just plug in 1 over 20. So I'm gonna go to the calculator to show that, because I don't want to do any of those by hand. So let's see. So just a new document for me and a calculator. So I'm gonna say f of x is the cosine of the arcsine of 4x, right? And g of x, I'm going to say, is the square root of 1 minus 16x squared. So we have these things, right? So if I do f of 1 over 20, I get that. If I do g of 1 over 20, it's exactly equivalent. Like we wrote an algebraic thing for this crazy looking trig thing, and it's so useful to have that. And I also know that the domain of f of x is -1/4 to 1/4 inclusive. And the calculator also knows that. I don't really know how the calculator knows that, but it does. It's like super good at it. So what I'm gonna do one more in this video, I guess, and then I will come back in the next video and do some more of it. And see, there's a really daunting problem kind of looming that I'm not sure if I'm gonna actually do or not. It's kind of like optional. It's basically that function that we graphed at the very beginning. Go through and do it. And do I want to do that? Probably not. But we'll see. All right, so I'm trying to do the tangent of the arc cosine of x over 2. So if I'm going to do the arc cosine of something, right? If I'm doing the arc cosine, let's say arc cosine of u, right? Then I know that u has to be stuck between -1 and 1. Otherwise, I cannot do the inverse cosine of it. In this case, u is equal to x over 2. So here I need -1 to be less than or equal to x over 2 to be less than or equal to 1. So I need -2 to be less than or equal to x to be less than or equal to 2. That's going to be my domain. Maybe. So, I mean, I think definitely, I should have said this on the last one. That's the biggest domain you could have. You can pick up domain restrictions because x can end up in denominators. But when that happens, you'll see it. So let's find out if that happens. So I'm going to draw a triangle. And then, so cosine is going to be x over 2. The missing side is 4 minus x squared. Call that theta. So I need tangent. So tan of theta is going to, so tan of theta is going to be radical 4 minus x squared over x. Okay, there's an issue here because the biggest domain I could possibly have was here, was -2 to 2. When I did the actual problem, x ends up in the denominator. You can't divide by 0. So actually my domain is -2 to 2, but x cannot be 0. So I have to account for that. So the answer that I write here, I'm going to say that the tangent of the inverse cosine of x over 2 is definitely equal to radical 4 minus x squared over x, provided -2 less than or equal to x less than or equal to 2, comma, x can't be 0 because you can't divide by 0. So like there's no way that x could be 0. So it's not like, it's not the biggest thought experiment to realize that x can't be 0, but you have to realize it. So there we go. All right, should I check that on the calculator? I guess so. Let's see how the calculator deals with the domain of this. So I'm always really skeptical of the calculator's ability to find domains because I guess it's because I don't really understand what it's doing when it finds them. I'm gonna do a new problem. But it's, for the most part, really accurate. I forget what I was doing the other day. I found something. Maybe you recently watched a video where the domain was not right. I don't remember what it was. It was like some value that it was saying was in the domain that wasn't in the domain. I don't really know. So I'm putting in the original problem, then I'm putting in what I got. And let's try to evaluate. So anything between -2 and 2 that is not 0 should work. So if we put in like, I don't know, 53 over 47, this, great. And then g of 53 over 47. Same value, because we got it right. Let's see what it claims the domain is. Domain of f of x, where x is the variable. Perfect. I don't exactly know how it's doing that. And that's why I'm like a little hesitant to just say like, always use that, but it works. It's really good. But I'm skeptical. You'll find in calculus, I'm equally skeptical of a lot of things the calculator does, even though it does them right, like basically every time. All right, so what I'm gonna do is stop this video here, come back in the next video and do more of the stuff on the page and then decide if we're gonna do the optional problem. So see you there.